The shaded figure below is formed by semicircles, quarter circles, and straight lines of length 20 centimeters each. It lies within a square of side 40 centimeters. What is the area of the shaded figure? Take pi to be 3.14. Okay, so in this figure, I don't think the shaded parts are clearly shown. So I've edited it. I've shaded the figure. So yeah, so as normal, the first step is to underline the main keywords. It's formed by semicircles, quarter circles, and straight lines of length 20 centimeters each. This is important, so yeah, and then it lies within a square of side 40 centimeters. That's also another important piece of information. So, what is the area of the shaded figure, which in this case is the total sum of green regions plus the total sum of these black regions? Yep. And we need to take the value of pi as 3.14. Okay, so this is a fairly simple problem. It's not so difficult as it seems. So the first step over here, okay, wait, for those of you who don't know, I'll be using this term quite frequently in this video. So just, okay, so the term is quadrant. And what that is, it's a quarter circle. It's basically a quarter circle. It's another term for a quarter circle. This part over here is a quadrant. It's also known as a quadrant. So just, I mean, you don't need to know this term right now, but it's good to know. Yeah. Okay, so what I was saying is that we can find the area of the shaded figure, of the shaded region inside one small square. And then since all these four small squares, 1, 2, 3, 4, since all of them are identical, we can find the area of the shaded region inside one square and then just multiply that by 4 to find the total shaded area in the figure. So let's get on with it. So first we need to find the area of this semicircle over here. And as you would know, the formula of finding the formula for the area of a semicircle is just half pi r square, which in this case you would have half times 3.14 for the value of pi times r square. Now over here we don't know what the radius of this semicircle is, but we do know that the diameter is 20 centimeters as given over here. The diameter is 20 centimeters, and we know that for any circle the diameter is 2 times its radius, which means that if the diameter is 20 centimeters, then the radius would be 20 centimeters divided by 2, which gives us 10 centimeters. So in this case you would have half times 3.14 times 10 squared, and then we get half times 3.14 times 100, which is the same as half times 314, which gives us 157 squared centimeters. So that's the area of one green semicircle over here. And now we need to proceed and find the area of this black region over here. Oops. Yeah. So if you see this black region is formed by subtracting the area of this quadrant from the area of this of this square. What means to say is we find the area of this whole square and then we subtract the area of this quadrant to find this region over here, the region in green. So that's fairly simple. We know that the formula for the area of a quadrant is just 1 by 4 times pi times r square, right? In this case we would have this is the area of a quadrant, and in this case we would get 1 by 4 times 3.14, the value of pi over here, times radius squared, which in this case your radius is 20 as given in the figure. If you see, this base of this quadrant is 20 centimeters in length. This quadrant over here, this length is 20 centimeters, which means that the radius would also be 20 centimeters. So we get 1 by 4 times 3.14 times 20 squared, which gives us 1 by 4 times 3.14 times 400. So this 4 and 4 cancel out, and we are left with 314 centimeters squared centimeters for the area of this whole quadrant. 314 centimeters squared. So now we have to find the area of this black region, which would simply be the area of this square, the small square, which is the area of the small square, minus the area of this quadrant, which we get as 20 times 20 for the area of the small square, minus the area of the quadrant, which is 314 centimeters squared, which would give us 400 minus 314 squared centimeters, which gives us 86 squared centimeters. So that's the area of this black region over here. So now we have to find the total sum of this black region plus this green region within one small square, and that would be basically this 157 over here plus this 86 over here, which is, so the total area of the shaded region in one small square is just 157 square centimeters plus 86 square centimeters, which would be 243 square centimeters, and that's within one small square. And if you see, we have 4 small squares over here, so we have to multiply this area by 4 to find the total shaded area inside the whole figure. So the total area, shaded area, the total area of shaded region in one large square is equals to 243 square centimeters times 4, which would give us 800 plus 172, 972 square centimeters. So that is your answer.